Hey guys, how's it going? Hope everybody's having a great day so far. Today we're going to be looking at how we can deal with overlapping encryption domains with site-to-site VPN connections in a checkpoint environment. And so I thought this was really interesting. I was able to lab out the whole scenario and get everything working. And I just want to take the opportunity to show you guys how you guys can set it up in your own lab and even maybe apply some configurations in your actual environment if this is something that's applicable to you. And so, of course, there could be a different number of different use case scenarios with overlapping encryption domains. But the one that we're going to use for today's example is, let's say one side has some type of server, whether it's a web application or some type of application that needs to be accessed, and it's residing behind a single IP address. That's what we're going to use for today's particular example. This can be repeated essentially with multiple IP addresses, but of course it can get a little bit out of hand if we're talking about covering an entire network. But just wanted to kind of set the tone for the video. And so to kind of go over the basic topology, we'll just have, let's say, two sides established across a site-to-site VPN tunnel, and with the same internal interface. In this particular case, it's going to be the 192.168.1.0/24 network on both sides. And then we're going to say there's a specific server behind firewall B that is 192.168.1.5. And we want to access that particular resource from a machine behind firewall A. And so just kind of in a quick nutshell, basically we're going to leverage NAT to translate, of course. And we're going to say, okay, everything behind firewall A is going to be coming from the 172.16.0.0/24 network, whereas we are going to NAT this particular IP address to 172.31.0.5. All right, so before we jump into the particular configuration on the SmartConsole side, let's take a look and see what we need to do from the Gaia web interface, or of course the command line if that's what you're more comfortable with. And so let's go ahead and take a look at the network interfaces first. And so the configuration that I went with was to leverage what's called a VTI, a virtual tunnel interface. Essentially, you can access that here in the network interfaces section just by going to add and then VPN tunnel. And so here there's two different ways you can configure a VTI. You can do numbered or unnumbered. Numbered is essentially going to have you create a local and a remote address on one side, and then on the other side, on the peer, you're going to have basically flip that, right? So the local address, let's say it's 1.1.1.1. On the other side, it would be 2.2.2.2, and then the local address would be whatever you have for the remote address here. Or you can also do what's called an unnumbered, which is essentially using a proxy interface to establish the connection. And in my particular environment, I went ahead and did a unnumbered, and then I just selected the interface that I'm using to establish the VPN tunnel. I just went ahead and leveraged that particular interface, so I didn't deal with the whole numbered stuff. And then tunnel ID, you're going to want to match on the peer side as well. And then here, it's just semantics. You can put whatever you'd like, ideally putting the firewall name of the peer. All right, so once you go ahead and have that configured here in network interfaces, just go ahead and do that on the flip side as well. As you can ignore that, it's a VMware error that I get once in a while. But yeah, go ahead and create that VPN tunnel on the flip side as well. Again, same VPN tunnel ID, proxy interface with my particular environment. And then what I also went ahead and did, and depending on your environment, you may or may not have to do this, but what I did was I went ahead and configured an IPv4 static route. And I said, okay, well, based on what the NAT that we're doing, anything going out to 172.31.0.0 on /24, just go ahead and send it out the VPN tunnel, because we know that's a unique IP range that we're using for the NATing. And same thing on the flip side as well for the peer. Anything that's going to the 172.16.0.0/24, go ahead and send that through the tunnel as well. All right, so that's pretty much the configuration that we have here on the Gaia web interface portal. Not much else was really needed to be configured on this end. So let's go ahead and take a look and see what we have going on here in SmartConsole. All right, so let me go ahead and make this a little bit smaller for you guys. Might be easier to see. All right, so we have the two firewalls. Just want to go ahead and show you the network management here. So we have our external interface on the 10 to 10 dot network. And then we have, like I said earlier, the overlapping internal interface. 192.168.1.1 is the internal interface on the /24 network. And then we do have the VTI, virtual tunnel interface, which does show up here in the topology. Okay, and again, we're using the proxy interface, so it's going to show with the same IP address. I'm using my external facing interface, which will be used to establish the tunnel. Okay, and I didn't really even have to mess around with any of the additional VPN settings. If you kind of look through some SKs and things like that, they'll say, you have to change this, come in here to user defined, use a dummy object, and things like that. I particularly didn't have to, but if you want to follow, I guess maybe some of the best practices, they say to do that for the route-based VPNs. But give it a shot in your environment or your kind of lab and see how it works out for you, and kind of go off of that. But I didn't really need to do anything else. For here, I just, of course, for my link selection, I'm using, again, the external IP address. And that's pretty much it. I'm just using the default VPN community. First, I'll go ahead and show you the topology here on the second one as well. It's the exact same thing. Again, 192.168.1.1 overlapping subnet. Okay, and we have the tunnel interface as well. And I'm just using pretty much the default my intranet VPN community for this particular example. What I did is I did set permanent tunnels, and I also made sure to uncheck disable NAT, since we're of course going to be leveraging NAT inside the community. But really that's it. I just left the rest of the settings here default. Of course, can change this based on your particular configuration. And I want to go ahead and just show you here, by not having the firewalls in the community, I'm going to go ahead and do a test ping before we jump into that, before I forget, let's go ahead and jump into the NAT rule. So we can see here, I just have two rules. I have a source NAT and a destination NAT. And we can see here, again, based on that diagram that we had up earlier, we can say, okay, well, anything behind the 192.168.1.0/24 network, behind firewall A, we're going to, again, NAT the firewall B server to the 172.31.0.5 address. So we say, okay, anything going there, let's go ahead and translate the source so that it looks like it's coming from the 172.16.0.0 network. And on the flip side, we have the destination NAT here, and it says, okay, well, anything coming from the 172.16.0.0/24 network that's going to this particular host, which again is the NAT address, let's go ahead and translate that to the real address, which is 192.168.1.5. Okay, and so these were the only two rules that I had to create. So pretty straightforward here. And so without further ado, let's go ahead and jump into the demo. So I'm going to be accessing an endpoint behind firewall A, which is a Windows 10 machine. And I'm going to go ahead and initiate a test ping to 172.31.0.5. Okay. 172.31.0.5. And we can see here, there is no reply. Request is timing out. So let's go ahead now and toss these two bad boys into the community. And let's go ahead and install the policy and see what happens. All right, installation succeeded. Let's give it a second just to kind of propagate, but it should already be up. So let's go ahead and initiate another ping. And there we have it. Tunnel's up, and we have a reply coming from 172.31.0.5, which just so happens to be this particular endpoint here on this side. But yeah, so there you have it. If you guys have any questions on a additional kind of configuration on my topology, feel free to reach out with any questions. Again, I just thought this was a really cool kind of use case and a great example to kind of go over and create a video to review. So I hope you guys kind of learned a thing or two. I guess before we close it out, I'll go ahead and kind of just show you some of the VMware settings that I have here, just to kind of give some additional insight. So I'll show you how I have the virtual network set up here. We have the VMnet 1, which is the external facing network, VMnet 2, which is on the internal interface on firewall A, and then firewall 2. We have VMnet 1 again, which is the external facing network, and then VMnet 3, which is on a completely different network. And of course, that's how the site-to-site VPN tunnel is transferring that information from the two separate networks on the inside interfaces. Of course, going through VMnet 1. And I'm just using that to get some internet on the machines. But yeah, that's pretty much it. So if you guys have any other questions, feel free to reach out. And thanks for watching and have a great day. Take care.